everyone, welcome to this part of the sequential circuits where we will discuss about the shift resistors. We will discuss about serial in, serial out, serial in, parallel out, parallel in, serial out, parallel in, parallel out, and universal shift resistors. So let's proceed. So what are the shift resistors actually? Last class we have discussed about the flip-flops, right? We have seen the conversion of flip-flops. So now we know what is a flip-flop. As a flip-flop, we know it can store only one bit of data, either 0 or 1. So it is referred to as a single bit register. Okay. When more bits of data are to be stored, a number of flip-flops are used. A register is a set of flip-flops used to store the binary data. The storage capacity of a register is the number of bits. Obviously, it should be ones and zeros of the digital data it can retain. Loading a register means setting or resetting the individual flip-flops. That is, you are giving the input data into the register so that their states correspond to the bits of data to be stored. And loading may be serial or parallel. Loading of data. In serial data loading, data is transmitted into the register in serial form. That is, one bit at a time. Whereas in parallel loading, the data is transferred into the register in parallel form, meaning that all the flip-flops are triggered into their new states at the same time. So parallel input requires that set or reset controls of every flip-flop accessible. A register may output data either in serial form or in parallel form. Serial output means that the data is transferred out of the register one bit at a time serially, and parallel output means that the entire data stored in the register is available in parallel form and can be transferred out at the same time. A shift register is a very important digital building block. It has innumerable applications. Registers are often used to momentarily store binary information appearing at the output of an encoding matrix. A register might be used to accept input data from an alphanumeric keyboard. Alphanumeric means it has both alphabets and numbers. Keyboard, and then present the data at the input of a microprocessor chip. Similarly, shift registers are often used to momentarily store the binary data at the output of a decoder. A shift register also forms the basis for some very important arithmetic operations. For example, the operation of complementation, multiplication, and division are frequently implemented by means of a register. A shift register can also be connected to form a number of different types of counters. Counter is a device that is used to count the clock pulses. We will see afterwards. These counters offer some very distinct disadvantages. So now, depending upon how data gets transmitted in shift registers are classified into different types. Okay, so we can see a number of flip-flops. When they are connected together, if they are connected together such that the data may be shifted into and shifted out of them, is called a shift register. That's what we have learned so far, right? So data may be shifted into or out of the register either in serial form or in parallel form. So there are four basic type of registers: serial in, serial out, serial in, parallel out, parallel in, serial out, and parallel in, parallel out. So the data may be rotated left or right, data may be shifted from left to right or right to left, and depending on, or it can also be shifted in a bidirectional way. Also, data may be shifted serially or in parallel form. Okay, so depending on that, we have different classifications of this shift register. So what is the first type? You can see this is the shift right, serial in, serial out. So data is, the input data is coming serially and it is also coming out serially. So that is why it is called serial in and serial out. But what is the flow of the data? From left to right. That is why it is called shift right, shift register. Over here you can see, this is also, here also the data is coming serially and it is also, the output data is also in serial format, but it is from right to left. That is why it is called shift left, shift register. Then here you can see the data is coming serially, but it is coming out, data is coming in serially, but it is coming out parallelly. Okay, this is what we call serial in, parallel out, shift register. Over here you can see the data is coming in parallelly and the output is also parallel. This is called parallel in, parallel out, shift register. Now you are seeing the data, it is rotating right. The data is rotating right, from left to right it is rotating. After this, whatever data is available here, this data is again coming over here. This is called rotate right, shift register. You just follow the direction of the arrow. Over here you can see the data, this data, it is coming from right to left, and whatever data is available here, it is going again from that last cell, the data is again entering and it is following that right to left format. That is why it is called rotate left, shift register. Okay, now what is this one? This is parallel in, serial out, because here the data inputs are in the form of parallel and the data output is serially. Serially the data is coming out. So that is why it is called parallel in, serial out. Over here what is happening? Serial in, serial out. This is serial in, serial out. Data is coming in serial format. It is also coming out in the serial format, and also if here, and this may occur either from the left to right or from the right to left. If it is from left to right, what we will call? We will call it shift right, right? And if it is from right to left, we will call it shift left, right? Now, first we will see what is serial in, serial out, shift register, and how to form this kind of resistor. What we can see over here, these are the D flip-flops, right? So, and all these D flip-flops are positive edge triggered. That means the positive, whenever the flip-flop will get triggered when the positive edge of the clock pulse is appearing. Okay, so data, serial data you are giving, and you are collecting the data serially also. So this type of shift register accepts the data serially from here. That is one bit at a time, and also outputs data serially. So over here you are observing the logic diagram of a 4-bit serial in, serial out, shift right, shift register. Why shift right? The data is going, the direction of the arrow is from left to right. Okay. Why it is 4-bit? That is why we are using the 4 flip-flops, right? With 4 stages, that is 4 flip-flops, the register can store up to 4 bits of data. Serial data is applied. You are applying the serial data at the D input of the first flip-flop. This is your first flip-flop, and the Q output of the first flip-flop is connected to the D input of the second flip-flop. So in D flip-flop, what happens? Whatever you are giving at the D input, when the clock pulse is active, the same output you are getting, right? So whatever serial input you are giving over here, the same output you are getting at Q1, and this Q1 is directly connected to the D input of the second flip-flop. So the same data it is receiving over here, right? And this Q output of the second flip-flop is again connected to the D input of the third flip-flop, and the Q output of the third flip-flop is again connected to the D input of the fourth flip-flop, right? So the data is outputted from the Q terminal of the last or the fourth flip-flop. So when the serial data is transferred into a register, each new bit is clocked into the first flip-flop at the positive going edge of each clock pulse. So these operations will be active only when the positive going edge of the clock pulse is active. Okay, so in each case, each new bit will be clocked. Okay, the bit that was previously stored by the first flip-flop is transferred to the second flip-flop provided the clock pulse is active. Positive going edge of the clock pulse is active. Okay, the bit that was stored by the second flip-flop is transferred to the third flip-flop, and so on. And the bit that was stored by the last flip-flop is shifted out. Next, you can see this is serial in, serial out shift register. It is a left shift register. From the last flip-flop, you are giving the serial input, and all the flip-flop is clocked simultaneously with the positive going edge of the clock pulse. So here the data is getting shifted from right to left. Finally, you are taking the final data from this fourth flip-flop. This is the serial output. Okay. Now, what is serial in parallel out shift register? So this figure over here, what you are observing is serial in parallel out shift register. So in this type of register, you can see the data bits are entered into the flip-flop or into the register serially, but the data stored in the register is taken out in parallel form. So for the first flip-flop, you are taking out this data. For the second flip-flop, you are taking out this data. For the third flip-flop, you are taking out this data from here. For the fourth flip-flop, you are taking out this data. Okay, so once the data bits are stored, each bit appears on its respective output QA, QB, QC and QD, and all bits are available simultaneously. All these QA, QB, QC, QD are available simultaneously since you have provided the positive edge of the clock pulse to all the flip-flops simultaneously, right? Rather than on a bit by bit basis as with the serial output. Okay, the serial in parallel out shift register can be used as a serial in serial out shift register if the output is taken from the Q terminal of the last flip-flop, but you are taking the output from the Q terminal of each flip-flop, right? So that is why it is called serial in parallel out shift register. If you have not taken all these QA, QB, QC, and if you had taken the output from the last flip-flop, then it would have acted as a serial in, serial out shift register, which we have seen previously, right? So let's move on to the next part, which is parallel in, serial out shift register. So what is parallel in serial out shift register? In this parallel in, serial out shift register, the data bits are entered. The data bits are entered simultaneously into the respective stages on the parallel lines rather than on a bit by bit basis as with the serial data inputs. But the data bits are transferred out of the register serially. That is on a bit by bit basis over a serial single line. So here what you are observing, it is a 4-bit parallel in serial out shift register with D flip-flop. Okay, so there are 4, you can see over here, there are 4 data lines A, B, C and D. There are 4 data lines A, B, C and D, from which you are giving the input data to your flip-flop. Okay, in parallel form. Through all these A, B, C and D, the data is entering to your flip-flop in parallel form, right? So this over here you can see there is a signal called shift or load bar. It allows the data that you are giving from here, the data to enter in parallel form into the register, and the data to be shifted out serially. The data to be shifted out serially from the terminal Q4. All right. When this shift or load bar signal is high, what will happen? This shift or load bar signal is this is the, if this shift or load bar signal is high, what will happen? The gates, this G1, the gate G1, the gate G2 and the gate G3 will be disabled because you are giving 1, but ultimately it is getting 0 because there is an inverter over here. So G1, G2 and G3, they will be disabled, and this G4, you are taking directly. So G4, G5 and G6, they are enabled. Okay, so it will allow the data bits to shift right from one stage to the next stage. When this shift or load signal is low, what will happen? The gates G4, G5 and these G6, they will be disabled, whereas these gates G1, G2 and G3 will be enabled. So it will allow the data input to appear at the D inputs of the respective flip-flops. Okay, when you are applying these clock pulse, these data bits are shifted to the Q output terminals of the flip-flops, and therefore the data is inputted in one step. Okay, the OR gate, these OR gate, it allows either the normal shifting operation or the parallel data entry depending upon which AND gate is enabled. Okay, by the status of this shift or load input. All right. Next, we will discuss about parallel in, parallel out shift register. Data is also entering in the parallel form to the shift register, and you are taking out the data also in parallel form from your register. So in this type of register, data is entered into the register in parallel form. As you can just notice the A, B, C and D inputs, and also the data is taken out from the register in parallel form. Just see the QA, QB, QC and QD. Immediately following the simultaneous entry of all the data bits, the bits appear on the parallel outputs. So this figure shows the 4-bit parallel in, parallel out shift register. Using the D flip-flops, data is applied to the D input terminals of the flip-flops. When you are applying this clock pulse at the positive going edge of the pulse, the D inputs are shifted into the Q outputs of the flip-flop. The register now stores the data. The stored data is available instantaneously for shifting out in the parallel form. All right. Now we will discuss about the universal shift register. What is universal shift register? This type of register is capable of shifting in one direction only if it is a unidirectional shift register. One that can shift in both direction, we will call it as a bidirectional shift register. Okay, if the register has both shifts and parallel load capabilities, it is referred to as the universal shift register. So a universal shift register is a bidirectional register whose input can be either in serial form or in parallel form, and whose output can also be either in serial form or parallel form. Okay, so if it is a shift register, if it is a general shift register, we know what are the criteria of a general shift register. A clear control to clear the register to 0. You can see over here this clear signal, one a cleared signal is applied over here. This clear control is to clear the register to 0. Okay, a clock input, we know why we give clock input to the register, to synchronize the operations. A shift right control to enable the shift right operation, and serial input and output lines associated with the shift right, right? Why we use the shift left control? To enable the shift left operation, and serial input and output lines associated with the shift left. A parallel load control, why it is used? To enable the parallel transfer and the N input lines associated with the parallel transfer. All right. Now, then a shift register can have N parallel output lines. It can have a control state which leaves the information in the register unchanged in the presence of the clock. So here what you are observing, it is a universal shift register, and here apart from the flip-flops we have multiplexers also, right? So this figure, it shows the logic diagram of a 4-bit universal shift register. So, and it has all the capabilities that just I mentioned now. Okay, so it consists of 4 D flip-flops. You are observing 4 D flip-flops, right? The 4 multiplexers are present over here, and these 4 multiplexers, obviously they will have 2 selection inputs, S1 and S0, and these selection inputs are common to all the 4 multiplexers. Okay, the input 0, these are the input lines. So input or data lines. The input 0 in each multiplexer, it is selected when these S1 and S0 select lines are 0, 0. 1 is selected, S1, S0. Obviously, you consider S0 is a LSB and S1 is a MSB. So, you will be selecting S1, input 1 is selected when S1 and S0 is 0, 1, and input 2 when it will be selected when S1 and S0 is 1, 0. Input 3 will be selected when S1 and S0 are both 1, 1. Okay, so the selection inputs, these selection inputs control the mode of operation of the register according to the function entries in the table. Okay, when S1 is 0, 0, 0, no change, register operation will be no change. When S10, S01, it will be shift right. That it will, the register will perform the shift right operation. Now, if S11, S00, it will be shift left operation. If both are 1, it will perform as a parallel load, because universal shift register, it can perform all the operations. So, when S1 is 0, they are 0, what happens? The present value of the register is applied to the D input. Okay, to the D inputs of all these flip-flops. This condition forms a path from the output of each flip-flop. This condition will form a path from the output of each flip-flop into the input of the same flip-flop. This is the clock signal, this is the cleared signal. Okay, so the next clock edge transfers. When the next clock edge comes, it transfers into each flip-flop the binary value it held previously. Okay, so, and no change in the state will occur. When S1, S0 is 0, 1, the terminal 1 of the multiplexer inputs have a path to the D input of the flip-flop. Okay, this causes a shift right operation. That's what we have seen from the table, right? And with the serial input transferred into the flip-flop 4. Okay, this serial input transferred into the flip-flop 4. When S1 is 0, it is 1, 0, what happens? A shift left operation. A shift left operation results with the other serial input going into the flip-flop. Okay, this is Now when S1, this is my flip-flop 1, right? So when S1 and S0, they are 1, 0, what will happen? A shift left operation results with other serial input going into the flip-flop 1. Okay. So when S1, S0 both are 1, 1, when S1, S0 both are 1, 1, what will happen? The binary information on the parallel input lines, what will happen to them is transferred into the register simultaneously during each clock age. Okay. So what are the application? What are the application of shift register? If we study about the application of the shift register, applications of shift register is used as parallel to serial converter that we have seen, which converts the parallel data into serial data. It is utilized at the transmitter section after analog to digital converter ADC block. Shift register is used to serial to parallel converter, which converts the serial data into parallel data. It is utilized at the receiver section before DAC, digital to analog converter block. Shift register along with some additional gates generate the sequence of zeros and ones. Hence it is used as sequence generator. It is also used as counters to count the clock pulses, which we will see in the next part.